event. All right, so today we're doing negations in DeMorgan's law, and it's really easy. It's really fun. Let's get this party started. The first part is the idea of a negation. What happens if you do? What happens if you negate not P? What do you get? Straight up P. This is called the law of double negation. All right, so we're going to list out a truth table for M and S, and we're just going to fill it in. So let's do that now. So here it is. We filled out our truth table, and we're going to try and figure out if we can see anything that's perhaps logically equivalent. We talked about that idea way back in the day, when you guys were just new people. What's up? Let's go with Chloe. Yeah. Yeah, it turns out these two things are logically equivalent. Logically equivalent. So let me just write that down. Oh, I said it doesn't always work and that you couldn't distribute it. But here it is. Here it is. What I'm going to prove to you is that there is a very special situation where it does kind of get distributed, and that's going to be called DeMorgan's law, right? I didn't even tell you I distributed it, right? All I did was just write down a truth table and kind of like plugged in my truth values, and it just so happens that these two are logically equivalent. Hold on one sec. Logically equivalent. What does that mean in terms of your mind? It means if you have something like this written in your proof, right? It is the same thing. Something else that is equal to it looks like this. And this perhaps might be more useful in some situations. Right? They are the same. They mean the same thing. You cannot have one without the other. So we're going to write down DeMorgan's law. I mean, that really is DeMorgan's law, but I felt like I should just give it to you in a more formal sense. You know what? I changed my mind. I was going to give it to you in a more formal sense, but I think this is the easiest thing for you to remember, right? I think that's easy because what will take place now that I'm thinking about all the problems that you guys will see and face. Like in a proof, you will see this, and then this will be the next step. And how will you justify it? You will say DeMorgan's law. I'll show you. I'll show you. Let me give you the formal version of it, okay? Let me show you the formal version. I'll write it down. So this is real fancy symbolism for DeMorgan's law. DeMorgan's law really just states if you see something in parentheses, a conjunction or a disjunction with a negation symbol on the outside, you basically distribute the negation symbol inside and flip the sign from whichever way it was originally, and the two are logically equivalent. So let's change it up. The biconditional symbol had messed with people a little bit. We just put an equal sign showing that the two are logically equivalent. Well, let's do number one. Negate, not P or Q. What do you get? Chris? Nope. Yeah, very nice. If you negate it, right, you're kind of invoking DeMorgan's law. You would get P, double negation, flip the sign, not Q. Right? That's what happens when you negate it. What's up, buddy? I was going to say Dale. Hold on, Hannah.
Okay. So it's.
Hannah, you tell me first. Go.
It's Hannah.
Tell me. What's up, girl?
Okay. So it's just
I see how you're kind of organizing in your mind. I don't necessarily know that you can make a link like that. It's kind of like it, I suppose. It could kind of go into the same kind of diagram. I could see how you'd want to organize it in your brain like that. but I wouldn't put it as the same thing. Like, don't make the link between this and the other one. Let's try something a little bit more formal, and then let's practice. Right? What's up? Yeah. Oh, another alternative? Sure. Alternative would be, like, I see what you're saying. Negate this to say something like this. Absolutely. Yeah, no, I'm totally okay with that. And then from there, obviously, you could move to here, right? Yeah, sure. So suppose you're given, now we're going to try our first hand at a little proof. And after this, you will have all the laws necessary to do ridiculous looking stuff. Yep, it's going to be fun. It's going to be real fun. So suppose you have something that looks like this, not P and R, right? And then I want you to prove. I want you to do something like that, right? Well, we got to set up our statement and reason proof. Write down all the given, right? Q and R, then P, not P, R. All this stuff is given. And then from here, we're going to have to strategize. So yeah, so that first step, we're going to pull it off of there. It's going to be modus tollens. What's next after there? Any ideas? Ben. Yeah, we're going to do DeMorgans law. Do you see how there's like a little tilde symbol outside of this? Ben, when you tell me you're going to use DeMorgans law, what do you get? What would you write down? And, not R. You got to flip that symbol. Oh, or. My bad. My B. Yeah, it's DeMorgans. Whoa. Okay. That's DeMorgans law. What else? What's next? What's do you think for? Dale. How do you know? Take this down, I'll explain it. So yeah, we got not Q. We got not Q by disjunctive inference because we knew R was true. That's got to be false, which means that this has to be true. Disjunctive inference. Okay,